Welcome back, my learners. It's time now we need to finalize the discussion of the special angles. That's 90, 60, 45, 30, and 0. Like the previous videos, which can be followed by the link down here, you will remember that we have already produced the trigonometric ratios of the angles. That's 30 degrees, 60 degrees, and 45 degrees. Now, let's see what it is about the 0 degrees, 90 degrees. It's more like making no sense at all for us to work out the value of the sine, tangent, cosine of an angle which is 0 degrees. How do we produce a triangle with 0 degrees? Look at that. And how do you produce a triangle with the 90 degree and another 90 degree inside? Let we know that the right angle triangle should have a 90 degree, and we expect the other angle again to be different one. It cannot be 90. So how are we going to do this one? Sine of 90, tan of 90, cosine of 90. Right, the same applies for 0. Right, so such difficulties are there, but here what we do now, we are going just to use some applications in mathematics. So the knowledge of which is there going to help us to come up with the trig ratios of those angles. Right, so like for example, what I'm trying to tell you is this one. Look at this. Say I've got a triangle like this one, which is right angle, ABC. This angle is 90. Yes, now it is right angle. And then issues about the trig here are really acceptable. You can work out the sine and the tan. But now if we talk of this angle theta to be 90 degrees, it's not all that easy in a right angle triangle. And again, this one being a 0, have to see a 0. A 0 is not an acute angle in this case. How is that going to be like? That we would get this angle being at 0 degrees. Then we have to work out the sine, tangent, and cosine as such. Right. So what we do as mathematicians, we bring in some kind of applications that will give us that knowledge. So what do we need here is just a circle. Of course, there are so many ways how you can handle this one out, but the better way, I would encourage you to use a circle, some kind. So let's discuss how we can come up with the sine. Let's begin with a 0, then we end up with what? A 90. Maybe let's begin with a 90 degrees, anything. Here, what we need is just a circle. Consider a circle of radius 1 unit. Consider that's a circle. I'm trying to buy more space here. With 1 unit radius. Right. This is what we need if we are to consider issues about 0 and 90. So if I'm to draw my circle, a circle will look something like this. And then at the center, I'm indicated and presented by a dot like that one. Let that one be a center, which is O. Right? And now I'll talk of the radius. I'll talk of any distance from the center going to the circumference, like this one here. This is my radius. Let me call it as ON. Right? So that is 1 unit. Now once I have that radius of 1 unit in this circle, let me also construct a right angled triangle. So additionally, having the radius of 1 unit, we need also to come up with a right angled triangle. Right. Because we can't talk of trigonometry if we don't talk of a triangle. So if obvious, we have to say a triangle in here. Right. So we need at least to come up with the right angle triangle here. So the right angle triangle that I'm going to produce here is a triangle that should have to be composed of the radius itself, which is that one, 1 unit, and this side should be regarded like your hypotenuse side. So let me have another side to have a complete triangle, which is just like a distance, which is the height of the triangle side, perpendicular to ON. So let me have O, this side here, be described as OP, while P lies on the circumference of the circle. So in short, let's have the circle, 1 unit radius, distance from here is 1, distance from here is 1. They're already done. Right, and the right angle triangle, which is defined as OP, let me have this one as H. Right, where P should be lying on the circumference of the circle. So when we talk about 0 and 90, this is a situation that we should always have. Circle, I repeat, 1 unit radius. And then use that one again to construct a triangle. That triangle will be something like this. Right. So what is it that now we're going to do? Our target is a 0 and a 90 degrees, of which we need to find their what? We need to find their trigonometric ratios. So in this triangle here, PHO, if we work on the sine, cosine, and tangent, we are always considering that the angles of which should be presented by this one. Right, so this angle can be presented as theta, so we're trying to make that theta should be 90, or theta should be what? 0 degrees. And as of now, we are able to see that if this is a triangle that we have, then we have to take that, say, our opposite side, in that case, to theta. Opposite side is that is PH, and the adjacent side is represented by line what? That is talk over OH, and finally talk of the hypotenuse side is represented by line what? OP. So if we are to work out everything about trigonometric ratios, we have to target the angle theta. So theta, this is the opposite side, this is the adjacent side, this is the hypotenuse side. So the theta now, we want it to be 0 degrees. So it's more like now, this one must be 0 degrees. But now the way it is here, this cannot be 0 degrees. As you can see, this is too much. And again, we want again to make the theta to be 90 degrees. As it is, this one is less than 90. It can be what? 90 degrees as it is. So in attempt to make this angle here talk of what 90 degree, such that at the end we have to work on the trigonometric ratios for the 90 degrees. Let's begin with the 90 degrees. You'll be able that it is not all that easy as it is here. So whenever we talk about this one as the way it is, if this one is 90, we carry no sense, because we always see that this one is less than what? 90 degrees. It's not 90. So what we do now is just like now, we have to bring in some kind of mechanisms of which issues about the trig ratios should remain as such, but we have to make sure that this angle has to be what? 90 degrees. So now, what we do is we are going now to try to make the theta to be 90. So when we talk of the ratios, those should carry sense. But as it is here, we work out this one as 90. We don't want those assumptions. But whatever we do should be exact. We have to really see that this is 90 degrees. So what we do now, for us to make this one 90 degrees, we have to do a certain activity, a practical one, that we really have to come and understand that this really is 90. So for this one to be 90, we need to move the point here, P, on the circumference of the circle. So as much as you can see here, if I will try to move P upwards like that, you'll be able to see that this angle here will be approaching 90 degrees. It will also be increasing. So for example, look at this one. If P comes to this position here, what will happen? You'd find that this line, OP, will now be like this. Look at this. As such, theta is increasing. Is approaching what? 90 degrees. So if I still keep on moving the P upwards, up to this level, you'd find that the theta is also what? Increasing. Until when this one is overhead the O, then definitely find that the theta will always be what? 90 degrees. So let's look at the system here. As P is going up, you'll be able to see that the following things will be happening in this figure. Look at this. As P is moved upwards, moving P, here is more like moving P upwards. The following things will happen. 1, theta is going to approach 90 degrees, and that is obvious. This one comes here. Right, if it was maybe 70 something, as of now, as we go up there, if it's theta will be above 70. And as P is going upwards, you'll also be able to see some changes of the what? Of the other sides of the triangle. You see that as P comes here, for example, you'll be able to see that H, talk of PH, will now be longer. Look at this. If P now is here, we have the distance. If this is a perpendicular distance, you'll be able to see that now the P will come there, and then PH will become longer. It'll be at the longer distance. So it means this PH is more like is approaching a 1, because it is this distance here, now it is this one here, something like that. So in short, as of now, let's just take that PH will be longer as theta as P is going upwards. Secondly, you'll be able to see that the line OH, which is there, as the P is going up, you see that H will not be here anymore, but H now will be here, if we are to maintain the right angled triangle. So it means talk of the OH will be shorter, but the PH will be longer. So let's look at the issue about shorter for the PH and the talk of the longer of the PH and shorter of the OH. What is it that is happening there? So it's like as the P was here, H is here. Now as P is there, you'll be able to see that H now is here. So if this P goes further to this position, maybe it comes to that position, you find that there's no way that H will be here. It means H will come somewhere here, which tells us a story that says this side area, it was defined as what? Adjacent side. Look at this one. OH was defined as adjacent side. So as P is moved up, in order to make this one as 90, you'll be able to see that H is more like approaching a 0. Because if this one, area it is 1, now it is here, it cannot be 1 unit. Now as you move P, then it means H comes here. It means that distance now is becoming shorter. As P keeps on moving, it means H now is approaching a 0. It means this one will be just like 0 unit at one moment in time as P is being moved. So here it means just like say talk of the talk of OH, which is adjacent side, is approaching what? A 0 unit distance. And again, if we can look at this one, this distance here, PH, which is our opposite side in this case, you realize that as P is being moved up, this one becomes longer. The longer issue here, it means like at one moment in time, much that you consider this one is 1 unit. This distance here, this distance, moreover, this is hypotenuse side here, hypotenuse side is 1 unit. It will be somewhere here. The P, this one, if P comes here, it means OP will be like this. Look at this one. OP will be this one, as much as this angle is being increased. As P is coming toward that point. It means this line again, as coming here to maintain the right hand triangle, this line, the whole of this one will be part and parcel of what? That is PO. So which means it will be like at the end, we'll just have one line like this one as P is being moved upwards. It means this OH, I repeat, will be like part and parcel of the OP. So if OP is 1, and this one is moved up, it means OPH will also be 1. But now this side, talk of OH will be like a 0, because just like H will be part and parcel of the O here. It has moved in order to maintain what? A right angle triangle. Right, so what we have there is just like as the P is moved up, it means theta is approaching what? A 90 degrees. By the time P will be on top of the O, right, it'll be like the angle there, theta becomes 90 degrees, and adjacent side becomes 0 unit, and we talk of the opposite side will be what? 1 unit. While the hypotenuse side, it will maintain itself to be what? 1 unit. That was happening here. So the idea is just a matter of moving a point P upwards. This one moves, I repeat. P moves, it is changing like that. It means several things will be changing. One, theta is increasing, approaching 90. And the OH will be reduced if we are to maintain a right angle triangle. So as this one is being reduced, it's more like this one is approaching a 0 unit because it is already less than 1, but that now distance has to be going smaller, smaller, or shorter and shorter until at the end that H comes here. So it's more like we will not have the value of what? OH. By the time P is overhead, the what? The O. It means here we have a 0. So let's take that, say, adjacent side will be 0 when we have theta as 90. Opposite side is 1, hypotenuse side is 1. That's what it would be like. So if we are now to work on the trigonometric ratios of the 90 degrees, we have to consider this situation here. The time we have our theta as 90, it means adjacent side will be 0. And the opposite side will increase little by little until when it is 90, that opposite side will be as good as the length of the hypotenuse side. Because the hypotenuse side here for the OP does not change. It is still the same line, the radius. Right. But this one will be part and parcel of the what? OP. So it means the HP, the opposite, and the adjacent side and the hypotenuse side will each one of them be 1 unit. Right. So that's what it is. So 90 degrees as an angle, adjacent side is 0. Opposite side will be 1, hypotenuse side is 1. So once you have known about these values, then for you to work out the trig ratios of the 90 degrees, it's very simple because you're just going to base on what you have with here. Right. Make that you know how to work out the tangent of an angle. So it's just like the tangent of 90 degrees. You talk of the tan of 90 degrees. Situation when now the angle is 90 degrees, you'll be able to realize that when you find tan, we just talk of the opposite divided by adjacent. So it'd be like now, if I've got 90 degrees, what is the value of the adjacent side? Adjacent side is 0. What about the talk of the opposite side? Opposite side is 1. So in that case, it means we're going to divide 1 by the adjacent side, which is 1 divided by 0. So 1 divided by 0, this is undefined. So there's no way you can have the value here. So tan of 90 degrees is undefined. Right. And then if you talk of the tan of, not tan now, but now talk of the sine of 90 degrees, the same situation. What you have yielded out of it are these values here. You can use them to work out the sine of 90 degrees. So sine is found when we divide the opposite by hypotenuse. So here it means you are going to divide 1 by 1. So the value of the sine of 90 is what? 1 in this case. You get 1. Then lastly, if we talk of the value of the cos of 90 degrees, how to find the cos? You'll be able to know that the cos is found when we divide that set of adjacent by the hypotenuse side. So if you look at here, your adjacent side is 0, and the opposite side, hypotenuse side is 1. So it means you're going to divide 0 by 1. So it's 0 divided by 1. The answer is 0. Right. So my dear learners, please consider this. When we talk of 90 degrees, a situation of which is what I have just elaborated on the board here. Right. So I'll just go through it a little bit for you to master this because it's very, very important. What I said is this. Please take note what you need to do. You simply need just to have a particular circle of some kind, just to summarize the discussion. Just have what? A circle of some kind. Radius being it 1 unit, consider that. So which means you can draw a line like that with the radius, then come up with the triangle, at least right arm triangle. Very important because we're talking of issues about what trigonometry. So you can have your triangle, something like that with a certain angle, which we always use an angle of what theta, which is always less than 90 from what we have started up with. Right, but now to have a right angle triangle in this case, you need at least to have another side like this one here. So that's a must. So you'll be able to consider that this line, always, this line is always 1 unit. Right, though this one again is also 1 unit, but not very important, but our target now would be this 1 unit here, distance. So you can have a point here like a P, this is O, this is maybe talk of H from what I've just said here. So an issue of this one being 90, that's now the C an issue. Right, so for this one to be 90, it's not just as it is like that one, it's not easy. So for you to make this one as 90, move this one upwards. So it'd be like now as you move this one upwards, you reach a point whereby this P should be on top of O. Then now this one is on top of O. What happens? It means that that is the situation now, this one angle will be what? 90 degrees. Otherwise, if this P does not come on top, there's no way theta can be 90. Right, it's must that P has to move upwards. That will make theta to increase to 90. Otherwise, it will not. So as we move this upwards, several things are happening in terms of the size of the triangle itself. What happens? As P is coming here, look at this one, it's coming here. This side here comes up, theta is increasing. And as theta is increasing, approaching 90, then we'll also be able to see that this line here is also increasing, coming upward like that one, and H is also moving towards what? O. So as H is moving towards O, is approaching O, definitely this one is just approaching a 0 unit. Area, if we can take from the start, this is 1, and we have H here is already less than 1. And if you keep on moving H towards O, as P is moving up, you'll be able to see that H is approaching a 0. By the time P is on top of, or say is perpendicular to O, definitely you see that OH is 0. You see that? And you talk of PH comes in as what? 1. It be part and parcel of the hypotenuse side, because this is already right angle. So it becomes 1. And talk of what? The hypotenuse side here, which is OP, that one does not change. It remains the 1 aside. So that's what happens. So move P upwards, then all the issues about the trig ratios for this kind will be found. Right, so now, can we fill that table on the part of the 90 degrees? Right, so I'm bringing this back. I'm not rushing. We need at least to understand how these things are coming from. That is mathematics. Right, so the other part of the table will be something like this. Right, above the 90, sine of 90, so take it from what we have found, we talk of the opposite of hypotenuse. So in this case, our sine becomes 1. So it's 1 divided by 1, so right here at the 1. What about the cosine of 90? Cos of 90 becomes what? From what we have found here is 0 over 1, which is just like a 0. And that of tan of 90 is 1 over 0, which is just like undefined, because you cannot divide 1 by any number by 0. It's meaningless. So here just write undefined, right. So that's it. So in the next meeting, we are going to finalize with a 0 special angle of what? That's a 0 degrees. What is the sine of a 0? What is the cosine of a 0? What is the tangent of 0? So please, my dear students, it's not that easy that these values don't just come, but all these activities we have done here, very, very important, and try to master issues about how do we come up with 30, 45, 60, 90. Right, so thank you very much. I have hope that in the last part of the trig ratios will also be together so that we have to master all the concepts here. Thank you.